A sailor checks the chart before dawn. Ahead, marked in neat blue lines, sits an island, close enough to reach before nightfall. The mark feels reassuring. Someone must have seen it, sounded its waters, named its shore, and placed it there for the next person. So the ship changes course. Hours pass. The sea stays open. No cliffs rise from the horizon. No birds circle above land. Only waves roll across the coordinates where the island is supposed to be. The crew checks the compass, then checks the chart again. The chart still looks certain. Their eyes do not. So how did an island that wasn't there stay on maps for nearly 200 years? This was not a single sailor's mistake, quickly erased by the next voyage. The island remained on maps, in atlases, and eventually on digital screens. Ships sailed toward it, researchers searched for it, and each time the ocean offered the same answer: nothing. In November 2012, an Australian research vessel set a course for the coordinates in the Coral Sea. The ship was the RV Southern Surveyor, a floating laboratory carrying marine scientists, technicians, and enough equipment to examine the seafloor beneath them. On the bridge, the supposed island was not treated like a vague rumor. It had a position. It had a name. It appeared on navigation charts and inside digital databases used by modern mapping systems. At roughly 19 degrees south and 159 degrees east, the crew expected the sea to change. They were looking for the signs an island leaves behind before it rises above the horizon. A sudden reduction in depth, a reef breaking the surface, perhaps a patch of disturbed water around submerged rock. The vessel's instruments were ready to detect all of it. But as Southern Surveyor entered the marked location, the horizon stayed perfectly open. No dark ridge appeared through the haze. No white surf flashed in the distance. There was only the long, unbroken line where blue water met blue sky. Then the seafloor readings came in. Instead of shallow water, the ship found deep ocean beneath its hull. The echo sounder sent pulses downward and received the return from a seabed far below, deep enough to rule out a hidden island or a barely submerged reef. The vessel crossed the coordinates, and the depth remained consistent. The crew checked again. Position, heading, charts, instruments. They moved across the location where Sandy Island was supposed to be, and the ocean offered no obstruction at all. Screen. The ship could have continued straight through the island's printed outline because there was no outline in the water. Only an invisible shape on paper and a digital mark on a screen. For the people aboard Southern Surveyor, this was no longer a matter of poor visibility or a difficult landing. They were not failing to find land. They were passing through the place where land was supposed to exist. Back on shore, the implications spread quickly. A feature carried across generations of maps had survived satellites, databases, and modern navigation systems without ever being there. The ocean had not hidden Sandy Island. It had exposed the map. That name belonged to Sandy Island, a reported patch of land associated with the whaling ship Velocity. Somewhere, in the 19th century, a sighting, or a position copied from one, entered the record. From there it began a strange second life. Cartographers placed the island on charts. Gazetteers repeated it. Digital databases preserved its coordinates long after wooden ships had vanished from the sea. But the original claim was never a proper survey. No one had traced a coastline. No boat had entered a harbor. No sounding line had measured the water around it. There was no confirmed reef, beach, cliff, or submerged ridge, only a report attached to a name and a set of coordinates. so the mystery is not simply why one expedition missed an island. It is how one uncertain 19th-century observation survived nearly 200 years, passing from logbooks to printed charts, then into databases and navigation systems, without acquiring the evidence that normally makes land real. Sandy Island had been recorded. It had never been checked. The first mark appears to have come from the whaling vessel Velocity, sometime in the 19th century, when a crew reported land in the Coral Sea. The report was brief. A position was written down, a name attached, and the sighting entered the world of navigation. That sounds more solid than it was. A ship at sea in the 1800s did not have a satellite fix, a digital depth reading, or a photograph waiting on a camera roll. Navigators estimated longitude with marine chronometers, but even a good clock could be affected by error, damage, or an incorrect starting positions. Latitude was easier, though not always easy in rough weather. Clouds could hide the sun. Swells could throw off a reading. A vessel could be hundreds of miles from where its crew believed it was, especially after days of wind, current, and dead reckoning. The velocity report entered that imperfect system as a possibility. It did not arrive with a surveyed shoreline. No one measured the island's width. No boat rowed ashore and described sand, trees, birds, cliffs, or fresh water. There was no harbor plan, no coastal sketch, no sounding survey, showing the seafloor rising beneath the alleged land. There was a position, a name, and the authority of a ship's report. That was enough to give the error its first fixed shape. A cartographer working from a nautical report did not necessarily have the means to investigate it. Charts were assembled from scattered logs, naval surveys, earlier maps, and information supplied by mariners. The work involved judgment, but also inheritance. A trusted chart maker's mark could be carried onto the next edition, especially when no newer voyage had clearly contradicted it. On paper, Sandy Island became a small, dark shape in the Coral Sea. Its coastline might be drawn in a clean curve, its name set in neat engraved letters, its position fixed among lines of latitude and longitude. The appearance suggested inspection. But the outline could be nothing more than a symbol occupying the space allowed by the map's scale. A doubtful sighting had been turned into something that looked surveyed. A printed chart has to make decisions. It cannot show every hesitation in the source material, so uncertainty gets compressed into a mark. A doubtful report becomes a dot. The dot becomes an island symbol. The symbol receives a label. Once that label is engraved, it looks less like a question and more like a fact. The same process could repeat without anyone deliberately falsifying anything. An atlas publisher might consult an admiralty chart. An encyclopedia might consult the atlas. A school book might copy the encyclopedia. Then, a later chart maker could compare several sources and find Sandy Island in all of them, mistaking repetition for independent confirmation. But those sources were not necessarily several witnesses. They could be one witness, echoed through several printing houses. The distinction mattered because maps carried reputations. A chart issued by a naval office did not look like a sailor's rumor. It had borders, grids, standardized lettering, and symbols shared with coastlines, surveyed inch by inch. Sandy Island sat among real reefs and real islands, rendered in the same visual language. Nothing on the page announced that its evidence was thinner. A reader scanning the Coral Sea could not see the missing history. No settled coastline, no landing account, no sequence of independent sightings converging on the same location. The map showed land, but not how that land had earned its place. By the 20th century, the mark had gained another layer of protection. Reference authority. Gazetteers and encyclopedias listed Sandy Island alongside other geographic names. Once a feature appeared in a reference work, its existence could be cited as if the book itself had verified it. Coordinates made the entry look even more precise. A string of numbers suggested measurement, and measurement suggested observation. Yet coordinates can preserve an error with extraordinary efficiency. They allow the same claim to be sorted, printed, indexed, and compared. A doubtful report becomes a plotted point. The plotted point becomes a named island. The named island becomes a row in a database. That final transformation is especially deceptive. A database entry has no weather, no uncertain handwriting, no tired navigator staring through rain. It presents a name, latitude, longitude, and perhaps a feature type, island. The original doubt has been stripped away by formatting. What remains looks objective because it has been organized. Digital maps inherited much of this accumulated material. Historical charts were scanned. Geographic names were transcribed. Existing datasets were merged. One database could feed another, and a map service could display the result without revealing whether the underlying record came from a modern survey or a centuries-old report. On a screen, a tiny island icon has the same clean edges, whether it marks a busy port or an unverified patch of ocean. The same symbol could represent a harbor crowded with cranes, or nothing but open water. That does not mean every cartographer blindly copied every predecessor. Mariners did update charts, remove dangers, and correct coastlines when new surveys arrived. But the ocean was too large for every feature to be independently revisited. A real island that mattered to shipping might attract repeated attention. A small, remote feature in the Coral Sea could remain untouched, especially when each new map inherited the confidence of the last one. So Sandy Island accumulated not proof, but paperwork. Its authority came from a chain of transmission, a report, then a chart, then an atlas, then a reference entry, then structured digital data. With every step, the record became easier to reproduce and harder to question. The mark did not grow stronger because someone found land there. It grew stronger because no one removed it. The first serious challenge did not come from a newer atlas. It came from a ship pointed straight at the mark. In November 2012, the Australian research vessel Southern Surveyor was working in the Coral Sea. Its scientists were not setting out to hunt a phantom island. They were studying the sea floor, collecting measurements across waters that had been crossed many times but were still poorly mapped in detail. Then the old coordinate entered the plan. Sandy Island was supposed to lie roughly halfway between Australia and New Caledonia, in a remote stretch of the Coral Sea. On a paper chart, it was a small obstruction in the route. On a computer screen, it appeared as a dark shape surrounded by blue. The team could have passed nearby and left the question unresolved. Instead, they chose the most direct test available, run straight across the coordinates. That choice changed the question. They were no longer asking whether a database contained an island. They were asking what a ship equipped to measure the ocean beneath it would encounter at the exact spot where the island was supposed to stand. The Southern Surveyor carried positioning equipment far beyond anything available to the 19th-century navigators, whose observations had seeded the claim. Satellite navigation fixed the vessel's location continuously. Its instruments recorded the track, speed, and heading, while a multi-beam echo sounder sent pulses downward and built a cross-section of the seafloor beneath the hull. An old navigator approaching an unfamiliar island had far less to work with. A sextant measured the angle between a celestial body and the horizon. A chronometer helped calculate longitude, if it stayed accurate and was carefully maintained. A lead line could test the depth, but only at one point when the crew decided to lower it. Clouds, currents, imperfect instruments, and so much of motion, and a single mistaken reading could shift a ship's position by miles. Those methods were astonishing achievements, not careless guesses. They carried ships across oceans. But one reported sighting could remain isolated. There might be no photograph, no soundings, no second ship, and no visible coastline to inspect later. Once the coordinates entered a chart, another navigator could inherit the number without inheriting the uncertainty behind it. The 2012 expedition attacked the claim from several directions at once. Satellite images showed no island breaking the surface. The navigation system placed the ship on the published coordinates. The echo sounder measured the water below. Then the vessel crossed the exact position where Sandy Island was supposed to be. Nothing happened. No reef scraped the hull. No shoal rose beneath it. No dark line of land appeared ahead. The ship simply continued through open ocean. The result was not a vague report that the crew had seen nothing. It was a measured crossing through the island itself. The water there was deep, far deeper than the shallow platform on which a low coral island or exposed sandbank would normally sit. Beneath the vessel, the seafloor dropped away into a broad basin. No hidden summit rose close enough to the surface to support the island drawn on the map. A real island can be uninhabited, hard to see, or briefly concealed by weather. It cannot be a dry patch of land while a research ship passes over deep water at its supposed center. The expedition did not watch Sandy Island sink. It did not discover ruins below the surface. It showed something stranger. The evidence for a charted island had never met the standard required for physical land. Even modern instruments need to be checked. A GPS receiver can report the wrong position if its signal is disrupted or its data are entered incorrectly. Sonar can miss features under certain conditions. Satellite imagery can be blurred by clouds, limited by resolution, or misread by software. Every measurement carries some uncertainty. But this case did not rest on one glowing screen. The ship's recorded track crossed the published coordinates. Satellite images showed uninterrupted ocean. Depth measurements contradicted a shallow island. Separate systems disagreed with the inherited mark and agreed with one another. That made the voyage more than a correction on a map. A map could copy an error. A ship could test it against the world. The Phantom Island also created a practical problem. On a classroom globe, its symbol looked harmless. At sea, that same symbol could send a captain around empty water, trigger a detour, or make a crew avoid a route that was perfectly passable. A few extra miles could affect fuel calculations, schedules, emergency plans, and the placement of future survey lines. For oceanographers, the empty coordinates became useful. They marked a place where inherited geography had to be separated from measured geography. Survey vessels could revisit such locations, compare old charts with new bathymetric data, and search for other features that survived, mainly because no modern ship had gone looking. The public lesson was less comfortable. Digital maps feel immediate because they update on bright screens, but those screens can conceal old sources, duplicated entries, and uncertain observations, and that's so much of motion. A satellite-style image may look like direct knowledge of the planet, even when the label beside it arrived through the same long chain of copying that preserved Sandy Island. In 2012, the ocean did not erase an island. It exposed the distance between a mark and a measurement. That distance matters because a map does not sit quietly on a page. It sends people somewhere. A captain plotting a route around New Caledonia could treat Sandy Island as an obstacle, a landmark, or a destination. A research vessel preparing an expedition might scan the surrounding waters for reefs, seabirds, shallow bottom, or any sign of land. Even when nobody sailed directly toward it, the island shaped the questions being asked about that patch of ocean. Then the information moved again. A printed chart became a digital database. The database fed a mapping service. The service supplied a screen in a ship's office, a university lab, or a government archive. With every transfer, the entry looked newer, cleaner, and more official, while its original source moved farther out of reach. That is how an error gains weight without gaining evidence. One map cites another. A database accepts the older record because it already appears in reputable charts. A later map sees several matching entries and mistakes repetition for independent confirmation. Sandy Island now has a history, even though nobody can point to rock, sand, or waves breaking above the surface. The strange part is that the island could influence events without physically existing. A navigator might alter a planned track. A survey crew might organize a search. A ship's report might record a discrepancy. An empty horizon could feel like a failed observation rather than the result everyone should have expected. The people approaching that stretch of ocean were not facing raw uncertainty. They were approaching an answer printed in advance. Maps have always done this in smaller ways. A non-existent road sends a driver down a dead end. A wrong border places a village inside the wrong country. A mislabeled reef turns open water into a hazard that demands caution. The mark becomes real in practice because people, machines, and institutions act as though it is real. Sandy Island exposes what happens when that process runs for 2 centuries. Authority preserves the error. Repetition hides its age. Digital coordinates give it a false sharpness. In a chart room, the mark may look more trustworthy with every new copy, while the original sighting disappears beneath layers of atlases, databases, and official records. The oldest mark can look the most authoritative. Its font is clean. Its coordinates are exact. Its source is buried so deeply that questioning it feels like questioning the map itself. But when was the last person actually there? Not when was the entry copied. Not when was it digitized. When did someone return with better instruments, clear weather, and a reason to doubt what everyone else had accepted? That question reaches far beyond geography. A medical assumption, an engineering measurement, or a historical claim can survive for the same reason. The record is repeated more often than it is tested. Sandy Island disappeared the moment a ship passed through its coordinates, but the mark had already done its work. It had redirected attention, shaped decisions, and turned empty water into a destination. The ship did not sail through an island. It sailed through 2 centuries of certainty.